Okay, so evac light is solid. This start is now solid. Before it was not. So we can't turn on the beam until we're at high vacuum or variable pressure is selected. So I'm going to go ahead and turn on the high voltage. Correct. You can do multiple samples. You can put as much on one of these as you want. Yes.
Okay. Among the plate inside.
So you could either use these are double-sided sticky. So the question was, you mount on these are conductive carbon sticky tabs. They make bigger ones of these. Sometimes they have copper tape. You can tape over something to hold it down.
My question: how can you how can you put a plate inside the chamber?
So it's screw. There's a screw on this side that so that sample holder we had, I would unscrew that smaller one and screw this one on. So yes. So right now we're seeing. So the red box on our map is our image here. So when I zoom in, see how that got smaller? When I zoom out, so this is what I'm looking at here. And I can zoom in and out on this map as well. Okay. So you see when we turn the beam on, now it's showing us what our accelerating voltage is. So we're at 20 kV, our emission current, our spot size, and our working distance. So where we're focusing our beam is our working distance. This is our magnification. So on the control panel here, we have a magnification knob. We have our stigmator knobs. We have our brightness and contrast, and our coarse focus and fine focus. You will find out that there are multiple places to do the same things, okay? Whether some people like using knobs, some people like using buttons, the mouse. So yeah, I like using knobs. So as you can see, as I'm changing my mag focus, if you can use the scroll wheel to change the mag. So when the mouse is inside the live image, you can scroll in and out with the mag. I like doing that as well. You can click on the mag box and then move the mouse left and right. That changes your mag. Or you can use your preset mag. So if there's certain mags that you use a lot, you can customize that as well. So you'll also find any of these boxes or windows, if you right click, it brings up more detail. Okay?
What is the IE and stop?
So IE is our emission current.
Okay.
So that is the current we're measuring up in the gun. So it's between our Wienold assembly and our anode. So our Wienold's basically our cathode. So that's what we're measuring.
So the current coming out of
Yes.
Yes. So this changes when we change our kV, and it also changes if we change the height of our cap. This microscope has what's called a variable bias. So what that allows us to do, no matter what accelerating voltage we're at, it keeps our emission current up high. So in the past, when you would go to a lower kV, your emission current would drop. So now there's relays that change the resistance for us, so it'll automatically. So if I want to change to 5 kV, it'll change my emission. It's actually going to jump up. We're actually going to have, well, okay, but actually 70 microamps is still very good for 5 kV.
So the working distance is usually around 10 millimeters, am I right?
The working distance for EDS is 10.
Okay.
when we do our analysis. Besides that, you can go any working distance you want. There's always pros and cons. There's always a trade-off, okay? Shorter working distance, better resolution. Longer working distance, better depth of field as well. So if you have a sample with different heights, different topography, it's better to go longer so then you can see more of that in focus. It's just like an optical camera. Same principles. So to change the KVs, you can click here and it shows the last 4 KVs that you used, and then it gives you more options here. If I right click, it brings up even more details, right?
So how do we know which KV to be used?
The question was, how do we know which KV we use? Trial and error. So you find out what works best for that sample. And it's depending on what information you want to get out. Okay, so I don't know if you had a chance to look at that pamphlet I sent you. So it shows the higher the KV, the stronger the beam, we're actually seeing below the surface, right? Where the electrons are coming from beneath the surface. If we want to see truly what's more on the surface, we go to lower KV. So if you noticed, when I did the pull down, 5 KV says surface. That's because our beam's not penetrating as much, and we're seeing really what's more on the surface of our sample, not what's below. Okay.
And I think it also depends on the conductivity of the sample. If it's not conductive, we usually go with the lower voltage.
Correct. So
Yeah. To
yes.
prevent the charging.
Yeah, a lower KV. The question was, if it's a non-conductive sample, another way to deal with charging is to do a lower KV as well. Yes. In the past, as well, the backscattered electrons are roughly the same energy level as our source. So if our source is 25 kV, our backscatters are just a little bit less than 25 kV. In the past, backscatter detectors were not as sensitive. So if you were below 15 kV, your backscatter signal was very poor. With this newer, more sensitive detectors, you can get backscatters at 5 kV. Very, very good. Also better though to be closer to the detector. So if we're long working distance, like I said, everything has a trade-off. You know, longer working distance, then we have less signal getting to our backscatter. Secondary doesn't matter as much. Secondaries are low energy electrons. We have to bias them to our detector anyways. That's one reason we cannot use secondary and variable pressure mode, because we apply 10 kV to our secondary. So at variable pressure, that 10 kV would arc, right? Because we're not under vacuum anymore, high vacuum. So that 10 kV would just go to, you know, path of least resistance. It would arc to ground. So
the definition between backscatter and secondary is basically based on contrast between the different materials.
So secondary electrons are low energy electrons. They are more, it's actually shows more topography. It's not going to show much difference in the elements.
Okay.
Backscatter actually uses Z contrast. So the higher the number, the more dense the material, the brighter it's going to be. Okay, so that's why carbon shows up darker. Even though we're using secondary, I'll show you. And in gold is brighter because it has a higher Z number than carbon. So backscatter is good for seeing dissimilar metals or materials. Sorry, not just metals, but different materials. Where
different materials densities.
Right. If this was gold and then silver next to it, secondary, you're not going to tell the difference. But depending on where they fall, The atomic number, yes. Okay, so this, you also have a picoamp meter built into this. So we're measuring the absorbed current, specimen current, which is very nice because I think you had one, they're very expensive. So this has it built into the system. So we can actually measure our specimen current. So accelerating voltage, emission current. The main thing with emission current is if it's at 0, what does 0 mean? Blown filament. Okay, we're getting no emission current. And you'll get a message saying 0 emission, check filament. And you would also, this indicator would also be red. Okay, so that's the main thing to worry about with emission current is that it's not 0. Okay. Spot size. Spot size is our condenser lens. So the bigger the spot, the more signal. So the bigger the spot that's hitting our sample. Bigger spot, more signal, more x-rays, but lower resolution, okay? Smaller spot, less signal, but better resolution. Imagine we're hitting our sample with a magic marker or a fine point pen. What's gonna give us a better resolution? The fine point pen, okay, better spatial resolution. We're not getting as much overlap onto the next section of sample. So
well, very similar to imaging with a 100x objective on my optical microscope versus a 10x objective, right?
Right.
100x objective is small spot size, lesser signal,
Right.
high resolution.
Yeah.
Same.
So changing the spot changes our condenser lens settings.
And how can we change it? Just click on that?
So yes, so if we right click, it'll bring down a menu. And and then it gives you suggestions too, right? Minimum damage, analysis is for EDS, a large analysis. So it gives you little recommendations, or you can do the slider and you can just see how it's much brighter. So we can do it, do a little example right now.
Do we need to do any kind of aperture alignment?
The question is, do we need to do any aperture alignment? Yes, and I will go over the alignment. If we change physically change the aperture, like I said earlier, we have 4 different size apertures. Each one is about half the size of the last one. So the largest is 120 micron, then it's 80, 40, 20. So the smaller the whole aperture, better resolution, better depth of field, but then you get less signal. So like it's just like an optical camera. So then once again, always a trade-off. But so we can see we're at 68 spot, and as I zoom in, that image looks okay, right? But it's still kind of soft looking, right? Soft around the edges. So we'll do an auto brightness. The edges aren't really sharp right now. So let's change the spot to 30. It gets dimmer. I do an auto brightness. Now I start to see some more detail, right? I'm starting to see the gold particles. That's just a quick example of going from 68 spot to 30. How much more? So now how do we get it even sharper? We slow down the scan speed, okay? Because we have a smaller spot that's hitting our sample, but we want that small spot to dwell longer. So then we're collecting signal. Okay, so another way to deal with that is just slow down our scan speed, which is here.
So what is the working distance right now on this one?
The working distance is 10, and I'm at 1000 mag. or I'm sorry, 11,000. 11,000. So the question was, why did we select 10 even though we're at SE
Yes.
right now?
Yeah.
So no matter what working distance we select, we can use any detector we want, whether it's secondary, backscatter. I just selected 10 because I know later on we'd be using the EDS.
Okay.
And so there's no constraint to what detector, imaging detector we use on the working distance. Maybe there was an option that we could start with backscatter instead of secondary.
Okay.
You can select what imaging detector you want to use, no matter what working distance you select.
You cannot use both the detectors at the same time.
The question is, can you use both detectors time? Yes, you can. So right now we have an image. We have emission current. We have our spot size, our working distance. So our working distance is our focus. So when I change my focus, this is where I'm focusing the beam, okay? When we measure our sample, the height of it, and we get it very close, our stage height, our physical height, and our working distance are going to be very close to one another. If they're not perfectly matched, that's fine. Not a big deal. So right now, I didn't move my sample. All I did was change my focus. So we focused on our sample, and our sample's right around 10 millimeters working distance. Magnification, we went over that. We have the knob. Auto functions. The auto functions on this work very well. You may use auto functions on other instruments. They don't work so well. These ones work really well, and they're very quick. So the first one is auto brightness and contrast. So if I manually change my brightness and contrast, I can come here. The next one is auto focus. So I'm going to defocus. Okay, so autofocus works very well. And then this is your auto stigmation. What stigmation is, our beam is not always perfectly round. So what we do is we electronically reshape the beam to make it round. So if our beam is oblong, when we go through focus, our image is going to stretch oblong. Okay, it's just like having astigmatism in your eye. You have to correct for that. Okay. You correct for the stigmation when you're at the high mag. It's easier to see it. So when you're at low mag, you don't really see the stigmation very bad. It's when you're at the high mag and you want to really sharpen up. It's the last step to sharpen up the image. So I tell people, think of stigmators as finer focus. So you have coarse focus, fine focus, and then I stigmate for that last finer focus to really sharpen up the image. So these are your auto functions. These are our different scan speeds. So right now we're at fast scan. So what fast scan is good for is navigating our sample, okay? So I like to zoom out, and now I can navigate around my sample. So you have the option to use a joystick, trackball, you can use the mouse, or we can click on the map over here, okay? The other nice part about having your own login, so for me, this joystick feels correct. For other people, it's opposite in their head. You can flip that in the software, okay? So you can invert it. So that's what's nice about having your individual logins, so you can set that up.
Now, when a user uses this instrument and the software, is there anything that is getting logged as well during each usage?
The question is, when the user uses the software, is anything being logged? There is a error file. So if any error messages pop up, those will get saved so we can check. But it doesn't necessarily, that's just for everybody. It doesn't say this user, you could go back and if you guys kept a log, there's a timestamp so you could figure it out. I mean, our goal isn't to try and like catch somebody like doing something wrong, right? It's just, you know.
Just to make sure that how can fix that.
Right, correct. So, no, there is an error log that's saved if there's any error messages, but it's not, it doesn't say who's logged in at that time. You'd have to keep track of that yourself. So fast scan is good for navigating, but it's still kind of a noisy image, right? So if I want to sharpen up the image, I just go to a slower scan and see how my signal to noise is better.
Where did you select? Oh, okay.
So you have, fast, and then you have one, you know, the higher the number, the slower the scan. So it just, and you can see here, it's showing, now it's a nice slow scan, okay? So then these scans would be more indicative of when we do our final capture, right? See how that's getting cleaner, more detail. The reduce scan. So I like to do the reduce scan when I'm doing my focusing and stigmating. Okay, so it's a smaller scan, but a faster refresh. So I can see things in live time. Okay, so you see how when I go through focus, the image kind of stretches in different directions. So I try and get it as sharp as I can with my fine focus, and then now I go to my stigmator knobs. So then go back to your fine focus and check again. See, now look how sharp that is. Now, you see how the whole image is moving. So I'm turning my stigmator knob right now. So I can stigmate, but it makes it a little difficult because my image is moving. We adjust that when we do the alignment. So we adjust our aperture, and then we balance our stigmator coil, okay? So the field on that coil is not balanced. That's why my image is moving. So we'll balance that coil to make it easier to stigmate. So we're not stigmating when we align it, we're just balancing that field, okay? So now after, so I usually like to go to a higher magnification than where I'm going to capture, focus, stigmate, and then I zoom out, and then I'll check it one more time, do a nice slow scan. If I like how that looks, then I hit capture. Okay. So now I'm capturing it to save the image. So every time I capture, it also saves it to the hard drive or thumb drive, wherever I want. And it's going to put it in this captured window, captured image window. So right now it's doing a 32-second scan. And because I didn't do the auto increment, it's going to ask me again, give it a name. If I click reference here, this is now just brings up your normal Windows. Where do I want to save this? Okay. So we'll just call it training, save. Okay. So now it's saved, and then it dumped it down into my saved images. Okay. And I'll show you later why that's important, or what's nice about that. So every time we capture, it now freezes this image. This image is frozen, and it says freeze here. So to unfreeze, we either come up to run or just click on any of the scan speeds again, and now it's back to a live image.
What aperture size are we using right now?
2. We're on aperture 2. So that's a good aperture. You want to at least use a aperture. You don't want to use it at 0, okay? 2's good, still good signal, plus we get lots of counts for EDS. Okay. If I'm trying to get the max performance, the best resolution, I'm going to go to aperture 4. I'm going to go to spot size probably 10 and working distance at 5. But I'm going to need to do a really slow scan to collect enough signal then.
How can we change the aperture?
So the aperture is mechanical, okay? And I'll show you that later when we go through the alignment steps. But we have to actually mechanically switch from one hole to the next. So.
Another question, can you show us how to rotate the part?
Yes, yes. I will show. The question is, we show how to rotate and tilt? When we get to this stage here, we will get there. we've kind of gone through these menus up here. Capture. Once again, if I right click, then change. I can do a 16. So maybe I don't want to wait 32 seconds. I can do 32, 64 seconds. So
in this case, of course, you can wait longer, but when you have charging, then you may want to do it quick.
Yes. So the question is, yes. So the longer your capture, the more the beam's dwelling, the more charging you'll get. This also has what's called CSS, charge suppression scan. So what it does, it's scanning every other pixel, and then goes back and scans that pixel the next time, and then puts that together. So there's multiple ways to deal with charging, okay? So when you see, if you see here, slow and then CSS, charge suppression scan. So they've thought of everything, right? Yeah. So we've kind of gone through the top here. So right now, this says advanced. I recommend leaving it advanced, okay? This is simple, like, right? But where's my KV, right? It doesn't show KV, doesn't show spot size. It just starts, shows mag. You guys can handle advanced, right?
It's so simple.
Yeah. So that's what that is, okay? This menu, I'll come back to this later. All right, so align. Someone was asking about alignment earlier. Okay, so when do we need to align? I like to check my alignment if I change my KV, if I change my spot size, because our crossover point of our beam is changing, okay? So the more you do this, you'll be able to get through it fairly quickly. And you see it doesn't change much, okay? But it's a good idea to get comfortable with checking our alignment.
What are we aligning here when you say align?
So we're aligning our objective aperture, the movable aperture. So we're aligning, so we want our beam to come down ideally in the perfect center of our column. Okay, so we're aligning the beam, and then we're aligning the aperture to the beam. We're aligning the stigmator coils, we're balancing them. So that's what we're doing when we're doing this simple alignment. So there is a more in-depth alignment, but that's only for when we put a new filament in. So I will show the power user who's going to be doing the filament exchanges, or whoever wants to see that. I can go over that as well. So the first one we do is aperture align. Okay. So what it's doing right now is it's focusing and defocusing the beam. So if our aperture was misaligned, and I'll show you what that looks like. You can see how the image is shifting left and right. So there's two ways to do it. So we can electronically move the beam to the aperture, or mechanically move the aperture to the beam. You don't want to do both, okay? Because you can start working against each other, okay? So if I mechanically change the aperture, I go to a different hole. I want to mechanically change the alignment, okay? But if I'm just changing my KV or my spot size, then we're just going to electronically move the beam to the aperture, okay? So all we're doing now is looking for big sweep. So now, so if the image is moving in the Y direction, we're going to adjust the Y alignment. If it's moving in the X direction, we're going to move. Pretty self-explanatory, okay? And you can also go to the reduced area here. Might make it a little easier to see. So the goal is to kind of just get it so it's just blinking, it's just pulsing in and out.
So do you have an auto alignment feature too?
For this step, no. Okay, so if you click on aperture and you don't really see it moving, don't adjust it. It's just if you see big sweeps, that's when you adjust it, okay? So now the next one is stigmator align. This one's definitely moving, right? We see it's moving in the Y direction, so I'm going to start. And now we kind of see it moving in the X direction. So don't worry so much about how it's stretching right now. Just worry about is the whole. So it's actually easier if you find like a particle or a piece of dirt or something and zoom in on that, right? If everything's kind of uniform, it's maybe hard to tell. So that looks good. Now we adjust the Y stigmator. Now it's moving in the X direction. And once again, this doesn't need to be perfect. It's just you don't want big sweeps because then it makes it harder when we use our stigmators to, okay? AFC align, autofocus course alignment. This one you rarely have to adjust. That one's barely moving at all. I wouldn't adjust that. Now I hit off, zoom in, focus, and now when I stigmate, my image moves just a little bit, right? But that's much easier to focus and stigmate. And I can always go back and double check it. Aperture looks good. The other thing to do, which is faster, is I hit this button and it toggles through these for me. So you'll get in the habit of clicking the alignment button. So I can do the alignment anytime. It's telling me here. And then just toggle through these. Okay? And then it's easier than clicking up here. So if I change my KV spot size, I hit this, toggle through, make my little adjustments. Okay. We can do an auto brightness at any time, and then check that slow scan. Okay. So that's alignment. Vacuum.